A developer console is one of the most powerful tools in game development. If you're looking for a way to integrate a developer console into your own project, stick around, because I got something special for you. Welcome back, everybody. Now, before we start going over how to install and extend this system, I just want to quickly cover some of the features that we have available here. So let's take this little guy for a walk and see what we can do. Move nodes. All right, so let's say we need to be on the other side of this wall, or worse, we're stuck in a wall. Now, normally if we were stuck in a wall, we would have to reload the application and get back to where we were and hope we don't get stuck in the wall again, but not with this system. So we'll just open the terminal, and the first thing we'll do is find our player. So we'll just call context.find and pass in the name player. Great, now we have our player. Now all we have to do is call node.move, and it's looking for an X and Y, so we'll move it 128 pixels to the right and 0 on the Y. And just like that, we're over there. Now, destroying nodes. Now we could just teleport to these, the other side of these spikes, the same as we did in the last one, but the system gives us another way to get our little friend over there safely. Let's just destroy these spikes instead. So we'll call context.find again, and this time we're looking for spikes. Now we have our spikes, and we'll just call node.destroy. Great, and now it's safe to walk over here. All right, loading levels. So let's say that we haven't added any level management logic to our game yet, or we want to test a level that isn't normally accessible from the one that we're in. That's easy enough to do with this system as well. So the first thing you do is come in here, and you just say level.getAll. And this is going to give you a list of all the scenes that are in this folder, res/levels. So as long as you create this folder in your project, this list will get populated automatically. And it's going to give you an ID number, the name, as well as the path. And to load this level in, we're going to load it in by ID number. And to do that, we just say level.load, and then pass in the ID number of the level we want to load, which is 0 in this case. And now you can see we're in a completely different level. Now, what about instantiating objects? So I come from a Unity background, and there's a difference between a scene and a prefab. In Godot, there isn't. A scene is just a scene. Everything is a scene. But I don't typically use that naming convention because I find it confusing. So in this system, if you want to instantiate a prefab into the scene, you'll do something like this. So the first thing we want to do is find our level, because we want to instantiate it into the level. And we'll just use context.find and pass in the name level. Now that we have our level, we'll just call prefab.getAll. And this is the same as level.getAll. We're going to get a list, except this time that list comes from a different folder. It is res/prefabs. So if you create a folder in your project at that location, it's going to be the information that gets populated into this list. And you can have subfolders as well. It works recursively throughout the entire directory there. And we do the same thing that we did with the scene, except we call prefab.instantiate. And we'll just pass in our ID again. We want the cherry, so we'll pass in 0. And this is going to spawn in wherever your mouse cursor is. And let's just send that command a few more times. And you can see that we now have some cherries in the scene, and we can pick them up. Great. Async tasks and cancellation. So this system's pretty extensible, and it allows you to use almost anything as a console command. And one of the things it allows you to do is use async tasks as a console command, and those tasks also support cancellation tokens. As long as you use the cancellation token that is built into this system, there is a provider for cancellation tokens in the dev console. As long as you use that to get your cancellation token, you'll be able to cancel the console command. So let's take a look at that. Let's do something really stupid and make our console generate a list of all the prime numbers between 0 and 1,000,000. So to do that, we'll just say math.listPrimes, and we'll start at 0, and we'll go all the way to 1,000,000. Now you can see that we have this operation running, but it's running in the background. It's not interrupting our game. We can still play, everything works just fine. And since I did use the appropriate cancellation token here, To stop this, I can simply call command.cancel. And now the operation's been canceled. So extensible and built-in help features. Like I already mentioned, this system can take almost anything and turn it into a console command. And there is a built-in help feature. If you just submit a question mark at the command prompt, it will give you a list of all the static console commands that have been implemented. And you can see that I put a few of them in already. There's actually quite a few of them here. And if you click the fold out, you'll get a brief description of what that console command does. We'll talk a little bit more about this later in the video and how you can add those descriptions to your own custom console commands. And lastly, it's more than just a command line interface. So I know a lot of people don't want to take the time to learn a whole brand new command line interface. And because of that, I created a completely different system that works on top of this. So if we open up our terminal, and we just click this visibility icon in the lower right, you can see that everything looks a lot different. And there is a context menu here, and there is a command menu here, and everything that is available to you in the terminal is also available to you here, but it also has some other more unique features. So we have this crosshair, and we can actually zoom out with the scroll wheel, and we can actually pan this around by using middle click. Say we zoom in on our player here, you can see that we can see the whole level, and we can move this all around. Another thing that we can do is if we hold we select our player and hold shift and left click, we can actually drag him around. And you can move anything that's in the scene by doing the same exact operation. Let's say we did something stupid and moved our player up here, completely out of the bounds of the level. We go back in, and there he is. You can see any changes we make in the crosshair mode are going to be propagated into the actual scene in the game. Let's just run this guy right off. And he's just going to fall into oblivion. Let's zoom out and see if we can find him. Here he is. There he is. You can see he's falling. Now how are we going to get him back up there? We have no idea where he is. The easiest way to do it is just to come to our room. We'll select the player. And then we go to Node and move to mouse. And we'll put our mouse here in this room and submit that command, and there he is, he's back. So now that you see kind of some of the things that this system can do, let's talk about how to install this system and a few of the settings that are included with the system, and then we'll talk a little bit about how you can extend the system to implement your own custom console commands. Alright guys, so to get started, things are going to be a little different this time. We don't actually have to clone the whole repository. We just have to download this file, and you can just right click this and hit save link as, or you can just click into it and there'll be a little download button up here in the top right corner. Once you have that downloaded, you'll have to extract those files into your project, and you will need an existing project for this to work. So if you don't have one already, you can just go ahead and create a new one for testing. And once you've done that, we'll just hop into Godot. And the first thing you're going to have to do in here is once you have this all extracted into your project, you'll see in the add-ons folder, there is a folder called Developer Console, and it's also going to add this demo folder for you as well. So let's go up into the project menu and then project settings. And the first thing you want to do is set up the auto load. So you're going to want to set the path to the scene_developer console scene. And that's going to be located in res add-ons developer console. And then you want to make sure that the node name is developer console with no spaces, and just remove the scene from the beginning of what's automatically populated there. Once you've done that, just go ahead and hit the add button, and it should add something that looks just like this down here. All right, so the next thing we want to do is just come over here to the General tab and go to Run, and make sure that the main scene is set to this scene. This is just going to make sure that we're all looking at the same thing when we press the play button. Before we actually take a look at the console, let's talk about some of the settings that are available. If you open up the scene that we just set up the auto load for, that is going to be scene_developer_console.tscn, and you click on the root node titled Developer Console, and then just come over here to the right and expand the settings. Now in here, you're going to see a couple of things. We have access level, print suppression, max autocomplete lines, and print license. And I'll tell you what all of these do. So the access level by default is set to with arg. Let's go through the list. So none. If you set this to none, that means that you will not be able to activate the developer console in any version of the game. It won't work in the editor, it won't work in a debug build, and it won't work in a release build. If you set this to debug, it will work in a debug build, or it will work in the editor. If you set it to with arg, which is the default behavior, it will work in the editor, it will work in debug, and it will also work in a release build as long as you provide a command line argument. And there's more information about this in the README file with the GitHub repository. And if you set it to all, it will just work everywhere. Okay, so onto print suppression. So by default, this is set to GD because I don't want things that are being output to the console being also output to the Godot output console as well. But you can come in here and you can set it to no suppression. So these messages will be printed in both places. You can set it to DC so that it will suppress messages in the developer console, but still output them to Godot. You can set it to GD, which is the default behavior that we discussed, or you can set it to all so that none of the messages will be printed. Max autocomplete lines. This is pretty self-explanatory, and this just controls the number of options that will be visible by the autocomplete system. And lastly, print license. So by default, when this developer console starts, it automatically prints a copy of the license to the top of the output. And if you don't want that behavior, you can just untick this box. All right, so let's just press play here and have a look at the console. And you can see we're in our little demo scene, and you're going to activate the console by pressing the backquote or tilde key on your keyboard. And you can see we've printed the license. Like I said, you can turn that off if you don't want to see it. And it works like any other developer console. You type a command, submit it, and it does a thing, right? So there's a command for getting the FPS. There are a lot of commands built in, and you can see all of the static commands that are built in by simply pressing question mark and submitting that. You can see there's quite a few that I've already put in. Not all of them are things that you're going to use, and you can add your own. We'll be doing that a little later in the video. Let's just talk a little bit about the output here. So the way that this works is by using a code edit control in Godot. So it has a lot of the features that the built-in IDE that Godot has. And if we click on the little dots here, we can expand that, and you'll see that we get this little description message. And that kind of gives us a brief overview of what that console command is going to do. Another thing that this system does is if you start typing, it will give you a list of options that fit the characters you've already put in. So this is part of the autocomplete system, and you can cycle through all of these, and you'll notice that it automatically populates the command prompt with whichever command is being selected here. And if you mouse over these commands, you'll see that it will show you that description as well. And you don't actually have to type the whole command. So you can see that I've only typed the EN, but the selected command is the get physics jitter fix. So if I submit this, it will assume that that's what I wanted to type, and it will just submit the entire command. Another thing this console can do is act as a calculator, which is a feature of questionable usefulness, but it does function. So if I type 2 times 2, I'll get 4. And let's say that I want like 450 divided by 5. It'll give me 90. And this will work with addition, subtraction, multiplication, and division. It doesn't support exponents, but there are a few wrapper methods for the math library. So if I type math, you'll see that there's a bunch of wrappers there. So if I wanted an exponent, I could just use math.pow and raise 2 to the power of 8, and it will give me that number. All right, great. Now let's say that we didn't want to actually type out the command. There's a couple of ways that we can get that command down into the command prompt. So the first way is just to do the old-fashioned copy paste. So the Control-C, Control-V, and that'll put it down there. But a shorter way to do it is just by clicking on the line numbers. So if I click on line 108, you can see that it copies line 108 to the command prompt. And there's also another little shortcut. If you don't feel like using the mouse, you can just type hashtag and then the line number 108 again, and it will copy it down there as well. And then to submit it, you just press enter. We're not going to do that because I don't want to clear the output console. Now, if you've been paying attention, you've probably noticed this orange text that says root that keeps popping up. Well, what is that? That refers to the context that the Developer Console is currently operating in. And if you're only using static commands, this is completely irrelevant. But what the system allows you to do is also use commands that only exist on an instance of a class. And those commands are not required to be static, but they are required to be called from the proper context. So in order to call those commands, we would have to switch the context. And there's a few different methods that we can use for doing that. If you already know the path to the node that has this command, you can just type it in. So /root/demo. And that's going to switch my context to the demo node in this scene. But if you're not sure of the path to the node, or you don't know which nodes are in the scene, you can also type context.getTree. And this is going to print a list of all the nodes that are in the scene. And the copying syntax is exactly the same. So if you wanted to copy a line, say down to the command prompt, you could just click on line 143, and now you've copied that path. And just by submitting that path, you're going to be switching the context. Now, if we type help with the question mark, you'll see that we get this big list of commands that we've already looked at. And that's great, but that doesn't include any of the instanced commands. So if we try question mark, this is only going to return a list of instanced commands. And you can see that this object has no instanced commands, so it's returned an empty list. So let's find an object that does have some instanced commands. So context.getTree again, and let's take a look. I know that this cross has instance commands, so let's set our context to that. And now let's try the same thing, question mark. And there you go. We can see that we have cross.toggleScale animation. So if I type that, there we go. You can see that the cross is doing a little scaling animation. All right, now let's just send that again so we can stop that. And if you want to do that, the last command that was submitted to the console is always remembered. And if you haven't typed anything in, you can just press up your up arrow and it will automatically fill that command in there. So let's just turn this off. There we go. All right, so that's pretty much a brief overview of kind of how this terminal system works. And you're probably thinking to yourself, like, this is really complicated. I'm never going to understand this. And it kind of is complicated, but you have to understand that it's a command line interface. And just like any other command line interface, like a Linux terminal, for example, there is a bit of a learning curve. And until you get used to how it functions and you learn how to use it, it can seem a little scary. But because of that, I've added kind of a novel approach to interacting with this console, and it's called crosshair mode. And to activate crosshair mode, all you have to do is come down here to the bottom right-hand corner and click on the visibility icon. And you'll see that the UI looks quite a bit different over here. Crosshair mode gives you a way to interact with the Developer Console without having to master all of the command line stuff. And all of the same functionality that's available in the command line is also available here. So we still have our command prompt and we can still type in our commands down here. And if we try get FPS, we'll see that the last output from the output console in the other view gets output down here at the bottom. And instead of having to manually type our paths to switch context, there's a little tree view up here that says context. And you can just click on anything here and it will automatically change your context, which makes this way simpler. And the same with commands. You don't have to type the commands. You can simply select the command from the command tree and you can send it. So if I want to toggle this move command on the triangle, I can just click it, press enter, and now the triangle is moving. And that's cool, right? But I can't see my whole scene. Like, what if there's something going on off the screen that I'm interested in, but I'm unable to see it here? Crosshair mode actually allows you to zoom in and out on your scene. So you can just use the scroll wheel to zoom out. And if you use middle click on your mouse, you can pan this whole thing around. And the other thing that allows you to do is you check your context, and you can see we have the triangle selected. So let's say I want to move the triangle. First, we'll just stop the triangle from moving by itself. And then we will come over here, select the triangle, and if I hold Shift and left click and drag, I can move this anywhere I want. And if we turn off or deactivate the console and we go back to the game, you can see that it retains that position. I'm actually moving the node in the scene when I do that. And that works for any of these. So I can move the square, I can move the circle. You can move anything. It really doesn't matter. So let's just try this toggle freeze on the circle. Yeah, it falls and bounces. And those are the instance commands. And you can also call all of the static commands from here. So let's say that I wanted to set the vsync mode to 0, so turn it off completely. I can do that. Now watch when I get my FPS. 3000 frames per second, right? And the reason it was 165 before is because vsync was on. And one of the great things about having a developer console is it does allow you to change these things on the fly directly in the build of the game. You don't have to go back to the editor to make these modifications. You can do it right there. So the people that are playtesting your game, if you give them access to this, it gives them a very powerful tool to test this stuff more thoroughly and rapidly than they otherwise would be able to if they didn't have something like this. Alright, now that we know how to use the console, let's hop into our IDE and start adding some custom commands. Alright, so into the IDE, I've just created a new static class, public static class called myCustomCommands, and let's just create a method in here that will print something to the console. So that's all we're going to need for the method itself, but in order to turn this into a console command, we have to decorate it with an attribute. Just like that. And let's say that we want to put it in a group with other console commands. We can open some parentheses here, and we can type prefix. And whatever we set this prefix to is what will be appended to the beginning of the name of this command. So we just put test here. That means that this command will now be called test.print-to-console. Test. And let's say we want to give it a description. We can just throw a comma. And we'll just say my test command. Perfect. So that's all it takes to add a static command to this system. And dc.print is the same as gd.print, except it works for the developer console. So let's go back to the game and test this out. And let's just go to crosshair mode. And now you can see that in our commands we have a new group called test. And inside test, we have print to console test, and it tells us that it's looking for a string. So let's just type something in here. It doesn't matter. And it has printed that to the console. And if we go back to the terminal view, you can see that that's exactly what it's done. So let's hop back into the IDE. Let's say that we want our method to return something that isn't void. Let's add a method that can do that. So there we go. There is a little method that can do that. Let's just decorate it and make it a console command. And we won't bother with the description. Well, let's go back to the game. Okay, into crosshair mode again. And let's expand test. You can see we have this new one. And this is add test, and it's looking for an integer A and an integer B, so let's provide those. Let's add 10 plus 35. We should get 45, right? And you can see, even though we didn't use dc.print, it has output that to the console. These methods can have any return type, and if the return type is non-void, it will try to print the result of that method to the console automatically, which is pretty cool, right? Let's go back into the IDE and check out some other types of console commands that we could implement. What if we wanted to implement some asynchronous logic? Well, we can do that too. And make sure we decorate it. Now let's just make sure we get this name right. There we go. So let's give that a test. And test. And here's our async test. It doesn't require any parameters, so let's just run it. You can see it says processing. And in 3 seconds, the task is complete. How about an async task that returns a value so we don't have to use that dc.print command? That should work. And back into the game, let's give this a shot. Async multiply. And we'll just do 10 times 20. And you can see we return 200. Perfect. All right, so let's just have a look at these two methods. And this is what controls the prime number generation that we used in the beginning of the video. So here's the token I was talking about. It's just command.token. As long as you use this as your cancellation token for your tasks, you'll be able to call that command.cancel console command to cancel those console command tasks. So if we look down through this, we'll see that is prime. It's just going to check if that is a prime number, and it takes in CT, which is our reference to that cancellation token. And that just returns task.run, and then all of the logic is inside of that. And down here in the actual console command that we called list primes, we're referencing that same command.token again, except in here we are awaiting that task from up there, the is prime task. So what we actually had to do to achieve that is run this task as a console command, and inside of this task we're running this task. So we have a task that runs another task, and it works perfectly fine as a console command. Like I said, this is a very extensible system, and you can use almost any sort of method for a console command regardless of the return type. And if you use a task, it will automatically be treated as async. Alright, so that wraps it up for all the static commands that we're going to be going over. And what about the instance commands? Well, everything that we did here with the static commands, you can also do with the instance commands. These console commands do not have to be static. So if you just had something that was on an instance of a class, it would work exactly the same way, and the system is still going to find it. You'll just only be able to call it when the context is set to that specific instance. So say we wanted to add a console command to one of the nodes in the scene. The node in the scene would have a script, and if that script had a console command on it, then you could call the method in that script directly from that context. And that's going to wrap it up for this one, guys. If you found this video helpful and you want to support the channel, please don't forget to like and subscribe. This one was a lot of work. That's why it took me so long to put it together for you. And we'll see you on the next one. Hopefully it won't take quite as long this time. Thanks.